Justin Gabriel R. Legaspi, and I'm here to present my designated task, which is at C. But before we proceed with the differentiation of acids and base, let's have a quick understanding of what the two are. Any hydrogen-containing material capable of transferring a proton or a hydrogen ion to another substance is defined as an acid. Primary examples of acids are inorganic chemicals such as sulfuric, nitric, hydrochloric, and phosphoric acids, as well as organic molecules belonging to the carboxylic acid, sulfonic acid, and phenol families. On the other hand, a base is a molecular ion that can accept an acid's hydrogen ion. Some common strong areneous bases include potassium hydroxide, sodium hydroxide, calcium hydroxide, strontium hydroxide, and lithium hydroxide. Acids and bases do have similarities with each other. They both react with water, and many acids and bases are naturally soluble. Acids and bases are both electrolytes, which means that they conduct electricity well. In an aqueous solution, both acids and bases create ions. This similarity between the two is where our first difference comes from. The ions that these two releases are not the same. Acids releases H+ ions into the solution, while bases release OH ions into the solution. Moving on, let's discuss another similarity that once again brings a difference alongside it. Both acids and base have a present hydrogen in their chemical formula. HCl or hydrochloric acid, also known as muriatic acid, is an aqueous solution of hydrogen chloride. It is a colorless solution with a distinctive pungent smell. For base, we have NaH or sodium hydride. This alkali metal hydride is primarily used as a strong yet combustible base in organic synthesis. As I've mentioned earlier, both of them have hydrogen in their chemical formula. However, they are not placed within the same order with each other. Acids present their hydrogen as the first element, while bases have their hydrogen as the last element. Moving on to our last difference, let's talk about differences in their conjugates. An acid is a proton giver, whereas a base is a proton acceptor. The substance generated after an acid donates its proton is known as the conjugate base, whereas the substance formed when a base absorbs a proton is known as a conjugate acid. Using H2 as an example, let's discuss the difference between the two. If we were to add a conjugate acid to our H2O, we are to add another hydrogen atom which turns the chemical formula into H3O. This is the chemical compound that is formed when a conjugate acid is added to H2O. On the other hand, if we were to add a conjugate base to H2O, we are to deduct the H from the chemical formula, which turns it into a OH. So this is the chemical compound that is formed when the conjugate base is deducted to H2O. Let's have another conjugate example. This time we'll have NH3. Once again, for conjugate acid, we are to add another hydrogen atom. On the other hand, we are to deduct a hydrogen atom if it were a conjugate base. If we were to add a conjugate acid to our NH3, we are to add another hydrogen atom which turns it into the chemical formula that is NHA. This is the chemical compound that is formed when a conjugate acid is added to NHA. NH3. On the other hand, if we were to add a conjugate base to NH3, we are to deduct H from the chemical formula, which turns it into NH. This is the chemical compound that is formed when a conjugate base is deducted to NH3. That concludes all the differences between acids and base that we have for today. But before we part ways, let me enlighten you with a special chemistry trivia. Chemistry holds power like no other, and in the hands of a wrongfully dedicated person, something monstrous can be produced. During the times of the most chemically utilized war, World War II, three substances were responsible for most chemical weapons, deaths, and injuries. So it is chlorine, phosgene, and mustard gas. A lot of lives were taken during this point. A lot suffered from slow, inevitable deaths caused by chemicals. We wish for this to never happen again, especially in this modern age of time. So that's all the time that we have for today. Like one Werner Heisenberg once said, not only is the universe stranger than we think, It is stranger than we can think. Thank you for listening. Have a great day.